Well, hello everybody and welcome. Over the past few months, I've been daily driving Fedora Workstation with some Arch Linux here and there. As some of you may have recently discovered, routine updates broke both Arch and its derivatives, as well as Fedora Silverblue, requiring some easy but very disruptive manual interventions. I've been running Debian stable on my servers, and of course they are as solid as can be. So I was thinking, lately, how could I leverage Debian stability and still run fresh kernels and software on a workstation? What about the Arch user repository? We'll find out right after this. To test as quickly and as painlessly as possible, I've downloaded the latest Debian stable ISO, link in the description below. So let's boot it on a fresh virtual machine. Here's the grub boot menu, and today, instead of the live Calamares installer, we'll be choosing the graphical Debian installer instead. Let's try that out for a change. And here we go, and here's the graphical installer. We're using the English language, and I am located in the United States. We'll continue here. My keyboard is American English, that's correct, so I'll continue. So it loads installer components from the installation media. It detects the network hardware. I've pre-configured the virtual machine for proper networking using DHCP, a private network, very secure. And looks like configuration succeeded. So we'll use the host name for this virtual machine, Debian 11-1. Click continue. We'll leave the domain name blank today. So we're not testing that. Okay, root password. Let me enter it once. And once again, for good measure. Click on continue. Full name for new user is, of course, Stephen. Username is Stephen, and I'll give myself a good password, good enough for today. Enter it twice to make sure I didn't typo. Configure the clock. The time zone for me is Pacific. Click continue. And the disk. So we'll use guided, use the entire disk to keep things as simple as possible. VDA is correct. And we'll put everything, all the files in one partition, one root partition. So it auto-configured for a swap partition, which we don't want. We'll configure ZRAM later. So let me delete this partition. And also we'll need to delete the root partition because we want it to fill the entire remaining space. Because we want two partitions, EFI, ESB partition, and the root partition. So let's create the new partition in the remaining free space. That's been vacated by the swap partition. It's no more. Yes, we'll use ext4, mount as root. That's the root partition. And it's only 1 meg left for free space. So we've got two partitions here. I'm going to click continue. Whoops. Yes, the Debian graphical installer can be a little tricky. We want to finish partitioning and then click continue. Okay, you've not selected any partitions for use of swap space. Yes, that's on purpose because we'll configure ZRAM later. So we'll say no here. We don't want to continue. Go back rather. And we'll go ahead with these two partitions. Number one is ESP or EFI partition, and the root is the rest as ext4. So let's let it install the system. So it's copying data to the disk and downloading and installing packages. Yes, we'd like to use a network mirror. And I'm in the United States, so we'll select from one of those. And I also like the Oregon State University Open Source Lab mirror. This is very fast for my location. Yours may vary. Okay, so it's configuring the repos and apt. And we're just about done here. Standing by. And now it's installing the group bootloader, rather. And there we go. Installation is finished. So we'll continue and reboot the machine after it removes some live packages first. Does a little cleanup. All right, and there we go. Our first boot of our freshly installed Debian stable Bullseye edition, XFCE. And we'll log in using the LightDM display manager. All right, looks pretty good. Standard XFCE. So I'm going to go to Applications, Settings, Settings Manager. Let's fix the screen resolution. Let's set it to 1920 by 1080. And click Apply. Keep this configuration. Next, on appearance, I prefer dark mode, as you guys probably know. For font rendering, I like slight hinting and RGB subpixel order. And for the custom DPI, we'll select 110. So that confuses the font rendering a little bit. So let me close the settings manager and reopen it. Make it a little bigger here. So for this demo, let's turn off display power management and screen blanking. All right, good. Looks like we're all set for our basic XFCE configuration. I'll leave it at that for today. So just as a reminder, running XFCE 4.16. This works, what I'm going to do, this works with multiple desktop environments. Doesn't have to be XFCE. So let's launch a terminal. And let's become root with SU. And there we go. So first thing is add ourselves to the sudo user group. So usermod ag sudo Steven does the trick. Let's turn off the root login with password-d root, which eliminates the password, which locks the root account, which is a good security practice. So let's add ourselves to sudo with new group. And let's test sudo. Sudo apt update. Ah, yes, it's asking for my password. And sudo is working for me. I can do things as super user. So let's do a sudo apt upgrade. Make sure our Debian stable installation is fully up to date and patched. This will take a while, so I'm going to edit out most of this process. Don't want to get you guys too bored. Never a good idea, I found. All right, it's done with the updating. So let's check the Debian version and under the etc directory. As it says, it went from 11.4 in this video to 11.5. So it's partially updated to Bullseye 11.5 release. So let's reboot and make sure our system is still functional after the updates. Okay, looks like it is. There's LightDM logging in. And here we go. All right. So moving right along, let's launch terminal. Let's make it a little bigger, full screen. So let's become root again with sudo-s. And let's check our RAM usage. So we've got 0 swap, we'll fix that momentarily. 486 megabytes used. So let's install the ZRAM tools for swap to ZRAM, compressed RAM. And once that's done, then we can modify the configuration file with echo-e in quotes algorithm or algo equals z standard, and then a new line \n % equals 40. So 40% of RAM will be ZSwap. And we'll add it with t-a to the end of etc default ZRAM swap file, which is the configuration file. So those are the two lines. Compression algorithm is z standard, and % equals 40. So this is what the file looks like. I just added these two lines. Okay, very good. So next, all we have to do is do a systemctl, reload, ZRAM swap.service. Okay, now our ZRAM should be functional now. We can check this by doing a free-h again. As you can see, we've got 3.1 gigs of swap assigned. So we're good. We've got a swap space ready to go. Let's install NeoFetch. And that's done. And let's run neofetch. So as you can see, running Debian GNU Linux 11, kernel 5.10, and yeah, latest XFCE and 538 megabytes consumed. Not bad. XFCE is rather light. So the installed system takes on the root partition 11 gigs. As you can see here, 18% of my virtual VirtIO disk. So let's add the sources for backports. So in etc app sources.list, let me add a section here. I'm going to mark it as backports. I'm going to do, since I'm a lazy typist, I'm going to copy paste the first two lines here. You'll see where this is going momentarily. So copy and then paste. So there we go. So in addition to main, I also want to add contrib and non-free packages to the available package list. I'll do this everywhere. Main, contrib, non-free. So we've got main, contrib, non-free. Okay, so I'm going to save some typing here by copy-pasting contrib non-free group. Add it to all these sections here. Whoops, double-click that by accident. Okay. Also for the backports. So all our repos contain contrib and non-free packages. And so here I'm going to add dash backports to the bullseye backports line here. So we've got access to the backports for our freshest kernel and other backported software packages. So let's test our sources.list by doing a apt update. As you can see, all our repositories are functioning properly. So let's install the latest mainline kernel with apt install linux-image-amd64-t, and we're going to choose the bullseye backports repo. And it found kernel version 5.18 from Debian 11.4 backports. So let's install it. So click Y here, let it install. So it didn't uninstall the old kernel, and we'll see that momentarily when we reboot. So if you go to advanced options, you can see we have 2 5.18 options and 4 5.10. So let's try the latest kernel, 5.18. Ah, it works. Fantastic. Backports are wonderful. So we're having Debian stable with the latest kernel for our newer hardware. At least my newer hardware. I need this for some of my machines. Okay, let's run neofetch again. Sure enough, there it is. Our latest Debian Bullseye backported kernel, 5.18. Much newer than the 5.10. Okay, let's sudo apt auto remove some stale packages that are no longer needed. So in other words, the old Linux headers. They're gone now. So moving right along, let's sudo apt install podman and crun, because I'd like to install an Arch Linux container for access to the AUR, right? Okay. So podman and crun are installed because I would like to grab a latest copy of Distrobox. So with curl-s https://raw.github-content.com/89luca89/main/install, and we'll pipe it to sudo as root a shell. And there it is. It installed successfully to user local bin. So let's check that. I don't trust anything, right? Trust but verify. Which Distrobox shows it installed in user local bin. Very good. Exciting. So let's do distrobox-create-image from docker.io/archlinux, the latest tag. And we'll call this container with name archlinux. So let's pull the image from docker.io. And it worked. It didn't download the icon, that's fine. We don't care about icons today. I'll leave that to you as an exercise. Distrobox, enter Arch Linux. It'll launch Podman with the correct parameters, and here we are. Stephen at Arch Linux. It was Stephen at Debian before. So let's sudo pacman-syy, because we're in Arch Linux now, right? Arch Linux userland with the Debian kernel. And let's check for updates. No updates. Let's install with sudo pacman-s neofetch base-devel and git, because I want to build the PARU helper. So let that all install, and it's done. So let's clear the screen. Let's run neofetch. As you can see, we're now on Arch Linux. We're running inside an Arch Linux container. We have the Debian 11 kernel 5.18. So it's just the userland that's different. So we're running at full speed here. Little to no noticeable performance loss doing this. And we're using very little extra memory, as you noticed. It's still under 700 megabytes. So let's git clone the PARU with https://aur.archlinux.org/PARU. And let's cd into the PARU build directory. And there's our package build from the AUR. So let's make package-si and build the PARU AUR helper, which happens to be my favorite. You can build others as well, like Yay or whatever you prefer. All right, and PARU's installed. Let's change to the home directory, clear the screen, and let's run PARU, and it's working perfectly. So let's remove the build directory with rm-fr PARU. And let's install with PARU Brave-bin, the binary release of the Brave browser, which I like very much. Installs a whole bunch of extra packages. And let's just go ahead with the defaults here. Just hit yes and Q everywhere and let it install. We trust the Brave AUR package repository. So let's run Brave. Let me make this terminal a little bit smaller. Ready for best privacy online, maybe later. And Brave launches from the command line brilliantly. And it works great. As you can see, it's full speed. It launches right away, no hesitation, no delay, just as if it were a native install on Debian. So let's export this with distrobox export --app Brave. So now Brave should show up in our main applications menu on XFCE and Debian. So let's exit our container and let's exit the terminal. Let's go up to applications and select internet, and there is Brave on Arch Linux. We also have the Firefox extended service release that's installed with Debian, right? So if we select Brave, as you can see, it launches instantly. Full performance. So that's how you run applications from the AUR on Debian stable. And you can just launch with under other, the Arch Linux box. Anytime you like a terminal for Arch Linux stuff, you can launch that. It launches immediately in your existing Debian XFCE session. Okay, so let's open up a Debian terminal. Stephen at Debian. Let's sudo apt install Flatpak. Because, you know, even though you're running Debian stable doesn't mean you can't run the latest, freshest Flatpak releases of your favorite software. So let's add the Flatpak repository with sudo flatpak remote-add --if not exists. FlatHub, and then https://flathub.org/repo/flathub.flatpak-repo. And we hit return here. This looks good. And it's done. Okay. So let's try this out. Let's go to our Firefox ESR browser that is included with our Debian installation. Let's go to flathub.org. And I like to install Spotify as an example. There it is, very popular app for your online music streaming service. And so we need to install the Flatpak with Flatpak install flathub blah blah blah. So let's copy paste it. There we go. And let it install all the dependencies as well. This installs in your home directory, doesn't touch your system itself. So, by installing this software that's run here, you will not mess up your system. And there it goes. So you can create a launcher here and whatever else you need if you'd like to launch Spotify from the menu. And that's all I have to show for you today. I've tested this on some of my newer hardware, and it all works brilliantly. Stability combined with access to the latest and greatest Linux tech seems like the best of both worlds to me. Since it's so modular, you can cleanly uninstall the Arch container and all the Flatpaks and easily get back to vanilla Debian if you want. Thanks so much for watching. Please show some love by liking and subscribing. Hope to see you again next time.